Hello and welcome to Monochemistry. Today we're going to look at a concept for AP Chemistry called the titration curve. And actually we'll also use this in Chemistry 12, so it's not just AP Chemistry. And to start off, I thought I'd take some awesome pics of the New Germany Rural High School Chemistry Lab. And so I just wanted to take a picture of a burette, which is the titration tool that we use. So right here we have our burette on a burette stand, and then over here we have an Erlenmeyer flask which has some acid in it, and up here we have base in here, and so we did a titration, and so you can see the universal indicator has changed color, indicating that we've reached the end point. Now we're going to talk a little bit about the different types of titration curves you're going to see. Also, we're going to talk about the difference between the end point, which is what I just talked about here, and also the equivalence point. And then I'm going to show you a picture of how the different ranges of different types of indicators and when might be best to use them. So let's start with the first type of titration, which would be a strong acid and a strong base. Okay, so in this picture here, which comes from your AP Chemistry textbook, we have a strong acid titrated with a strong base. Okay, and as you can see in this picture here, you started off with 0.0 milliliters of NaOH. In other words, this is what you're adding. You have an unknown concentration of acid starting off with a very low pH. Now, you can follow it along in the graph here too. As you add base to your acid, you can see what happens. At first, the pH goes up very slowly, and then all of a sudden, bam, it goes up very quickly. And that's why when a lot of people say, oh man, it was just one drop, and bam, it went all of a sudden. Well, that's why. Because you're going up very slowly. You're neutralizing your acid, and then all of a sudden, you've reached the equivalence point, which is where the acid has been neutralized. And one drop past that, bam, takes you way up to here, which would be a very high pH. Okay, but what do you notice? The equivalence point of a strong acid with a strong base is a pH. This is pH, by the way, on this side here. I should have not cut that off. pH, and down here is milliliters of base added, so milliliters of NaOH. What you notice with a strong acid and a strong base is that the equivalence point is always going to be 7. Now the end point is probably not going to be right at 7, because the end point is going to be when you see the color change. So we might have gotten to here and then added one more drop, and then bam, our color changed. Notice that the pH up here is like between 11 and 12, which is pretty high. That's where we would have seen the color change. So the end point is where you see the color change with the indicator, okay, indicating that the reaction has gone past the equivalence point. Okay, so the equivalence point is when the acid is neutralized, and the end point is when you notice the color change indicating that you've gone past the equivalence point. And it's the end point that you have to use in your calculations. Okay, so you should copy a picture of this down. You can use your textbook to draw it if you don't want to use the video, but you need a picture of what this is, and it's a good idea to have the data as well. The second type of titration curve we're going to look at is a weak acid with a strong base. Now, as you can probably imagine, if you have a weak acid, you're going to start off at a little bit higher pH. Again, we're adding a strong base, NaOH, and in this case, the equivalence point is actually going to be higher than 7. Now, why would that be? Well, it's because you've got a weak acid, and as we know, weak acids do not dissociate 100%, whereas this strong base is going to do that. So the strong base kind of overpowers the weak acid in terms of an equivalence point. And so our equivalence point should be, for this type of titration, should be above 7. So if you ever see a titration curve and the equivalence point, which is, by the way, if you just look at this line right here, it's the middle of this line. So you see how the curve works. You start off going very slowly. I should have mentioned this in the last slide. And then you see up here it increases very slowly, but there's a point right here where it jumps. It's the middle of this part right here. That's always the equivalence point. That's how you find it, because it's not always going to be marked like this. You're going to have to identify it. Okay, anyway, If the equivalence point is above 7, then this is the type of titration that you've had. The next type of titration curve we're going to look at is a strong acid with a weak base. Now, in this case, we're actually using the strong acid and we're adding it to the weak base. So the weak base is the unknown concentration in the Erlenmeyer flask. Okay, so we'd be adding the HCl, and so we're starting off at a much higher pH, and in this case you can see that here's the line where you see the big jump, and of course the center of that line is the equivalence point. Now, the strong acid with a weak base, the pH at the equivalence point should be below 7. Again, the strong acid kind of overpowers the weak base. The weak base doesn't dissociate as much as the strong acid, and so the pH at the equivalence point is going to be low, lower than 7, and that's how you identify it as a strong acid with a weak base. Don't forget, the equivalence point and the end point are different. The equivalence point is where the acid or base is neutralized, and the end point is where you can actually tell that the acid or base have been neutralized. Okay, so this is your titration curve. There's 3 different examples there, and I'm going to move on now and show you the different types of indicators and where they might work. We're going to try and figure out where they might work best. Okay, so we have these different indicators that work for different pH ranges. Okay, so when we did our titration in class, we used phenolphthalein, and notice that the pH range for phenolphthalein, you can see it starting to get pink, is between the 8 and 10 range. Now I know what you're thinking, but Mr. Monahan, we're trying to figure out when a strong acid and a strong base neutralize each other, shouldn't the pH range be at the 7 mark? And the answer, unfortunately, is no, because remember, the equivalence point is going to be here, and then one more drop after the equivalence point is going to give you that. So one little tiny drop after the equivalence point is going to give you that pink color, and that's how we use it. If it gave us a pink color right at the equivalence point, then we wouldn't really be able to tell where that equivalence point was. Okay, because the equivalence point always comes a little bit before. So it doesn't really make sense to have it be right here. And as you can tell, there's no indicator that goes right over 7. Neutral doesn't really indicate in any of these. So phenolphthalein is a good one to use for a strong acid and a strong base, because right after, you get that really nice pink color. Okay, what if I was using a strong acid and a weak base? Well, this one here might be a good one to use, because as you can see, it starts to get yellow around here, and then boom, it goes to a red color, methyl red. So I would be able to tell as I got closer and closer, because remember my curve for that would look like that. As I got closer and closer to the equivalence point, it would start to get yellow, and then bam, all of a sudden it would be red. So that one will work quite nicely. And then you have this one here, thymol blue, which can be used as well. Now, one thing we didn't talk about is a titration curve for a weak acid and a weak base. Now, one might think that because you have a weak acid and a weak base, that the equivalence point for those would be 7, but one would be wrong. Remember that when you're dealing with weak acids and weak bases, you have to look at the relative strengths of each of those things. So if you're reacting a weak acid with a weak base, it's not going to work out always to be 7 in terms of the equivalence point, because the weak acid might actually be a stronger acid with respect to its dissociation than the weak base. You have to compare the Ka and the Kb to really get a good idea about that. So if the Ka for the acid is 5.6 times 10 to the negative 10, and the Kb for the base is 2.6 times 10 to the negative 3, the base is actually much stronger than the acid, and therefore the equivalence point should be higher than 7. If the Ka is bigger than the Kb, then the equivalence point is going to be below 7. The only time that you'd have a pH equivalence point of 7 with a weak acid and a weak base would be if the Ka and the Kb were identical. Now, how often does that happen? That, in a nutshell, is titration curves and how you can use indicators to identify a particular type of reaction. Here are the references for this lesson.